Okay, everybody, so here we have a little bit of a different approach today. I will be trying to implement load balancing for first hop redundancy protocol. This equipment that you guys see here, this is my little lab that I have with me. The switch is a 24 ports switch. As you guys can see, it is a Catalyst 2950 series. The routers are the 2610XM. Okay, so this is only one fast Ethernet port and the console. So today the idea is that I will be performing load balancing. So the topology is going to be, the actual configuration will take place via console on this live equipment. So the cabling is going to be first from router 1. We're going to plug this over to port 23. Now this is a Cat 5 cable that I made myself, and also we're gonna plug this router 2. I'm going to plug this over to the switch on port 24. Okay, like so. And then the computer, I'm going to plug the computer over to port 1. Okay, so now we have our equipment cabled, and it's time to jump over to the computer and begin configurations. All right, everybody, so here we are in my CLI router 2, and I will go ahead and put myself, I'm gonna jump over router 1. And in this video, since we already completed the first hop redundancy protocol, specifically hot standby routing protocol, now in this video we are going to configure our routers to utilize gateway load balancing protocol. Now, the difference between hot standby and first hop redundancy protocol, which is the other version, which is the virtual router protocol, or virtual redundant routing protocol, is basically the first, which is hot standby routing protocol, is proprietary for Cisco, and they use the term the standby, the master, one standby, and then all the other routers are always listening. Whereas virtual redundancy routing protocol use the term master, and the other routers are backups. So another thing but the configuration is the same. It's only a difference in terms. One thing though that I like to point is that when you are using hot standby protocol, you need to have a IP address for your physical interface and a different IP address to the virtual interface. That's one key difference between the two protocols when it comes to configurations. In virtual redundancy routing protocol, you are allowed to use the same physical IP address for the interface to the virtual interface. So you can use the same IP address on both physical and virtual. That's one key difference there. Also, between timers, you can play around. One is 3 seconds for the listening, and the other one is 1 second. So there are some slight differences, but the configuration is virtually identical. So that's why I have not moved on to dive deeper into the virtual redundancy routing protocol, because since we already configured the hot standby routing protocol, is virtually the same. Now the difference is load balancing or gateway load balancing routing protocol, which is my favorite in my opinion, because that allows you, instead of just using one single router all the time and leave the other routers sitting there, right? I like the fact that with gateway load balancing routing protocol, you're pretty much making use of your redundant network, right? So you're making complete and full use of your devices, and it will help you greatly when it comes to the traffic that you're moving in your network. Now the default behavior when it comes to gateway load balancing, right, is that it will load balance between the routers in a round robin fashion, meaning that it's going to split your traffic in a 50-50 way. Now you can go deeper and more specific into, depending on your configurations requirements based on policy, whether it is because of security concerns or simply because you have a more powerful device that you wish to use as your main device for moving traffic. That solely depend on policy, right? But by default, you will distribute traffic on a network in a 50-50 way. So let's jump and configure these routers to utilize the load balancing configuration. So I'm right now on my router 1. Let's see if we can get into the CLI global config. All right, so let's go to global. Okay, so the first thing I like to do is that I want to configure the physical interfaces. So for my two routers, I will then use the last two IP address in my network range, in my IP addressing subnet. So for router 1, I will use the 253, and then for router 2, I will use the 254. And then I will configure, for the purpose of labbing or testing, I will configure a loopback interface with an IP address, the same IP address, in order to simulate a different network behind the routers, because physically I do not have anything connected behind my routers. So in order to simulate something like that, then I will configure a loopback. So loopback interface will function as a different network that will be used to test connectivity. So let's jump and configure the physical interfaces. Then after that, I will create the loopback. And then after that, I will repeat the same configuration on router 2. Then after that, I will create the load balancing configuration. So here we go to Fast Ethernet. And I will use for router 1 the IP address ending on 253. Okay, so IP address 10.0.0. Now, this is my network range. So my subnet will be inside a class C. Do a not shot. Okay. Now I can see that my interface coming up. Indeed, it is. Perfect. Now let's create a loopback interface. Loopback 1. And I would then make use of the IP address of 1. If I can type correctly. All right. Perfect. Okay, router 1, I want to be the active router, right? I want to be this router to be the main forward, the main device that will forward traffic, right? So it's going to be used with a higher priority. So I'm going to now start configuring the gateway load balancing protocol. In order to do that, I will have to go back to the physical interface configuration. Okay, so here we are. And then I will start configuring the gateway load balancing. And we're going to use the group 10 and an IP address of 10.0.0.1. Perfect. And then I will then, for this router 1, change the priority to 110. The default is 100. The router with the higher priority will be chosen as the active router. Also, I would like to configure the preempt. That way, if my router goes down for whatever reason, obviously router 2 is going to pick up the to be the active router. And later, if my router 1 comes back up, it will not reclaim its status as the active router, right? Unless I specifically tell the router with this command to reclaim its status as the active router, right? Now, I believe I'm done here, so let me switch to router 2. All right, router 2 is up. Okay. Whoa. enable. Okay, global config, physical interface, IP address, not shut down. Great. Okay. Loop back. 1 IP address. Not shut down, although I may not even have to, but I like to I just like to do it. And now let me configure the load balancing. Group 10, and we're going to then specify the IP address. Okay, I believe I have that 10.1.1. Okay, yeah, 10.1. Perfect. Okay. All right, now that we have configured that, I'm not going to change no priorities or configure the preempt. All we need to do now is to take a look at the computer. Computer has been already configured with the an IP address of the virtual interface. So this is the computer's IP address, and this is the IP address of the default gateway. Okay, which is the 10.0.0.1. Now, as you guys saw already, the actual IP address of the devices are 253 and 254. Now we can configure, or we can verify rather, our configuration with the show gateway load balancing. Now this is the longer version of it. In this router, router 2, the state is standby. Okay, perfect. And the virtual IP address is the 10.1. The hello timer is the default. We haven't changed any of that. We are not doing preemption. Okay. And my actual IP address is this one. Or the active, rather. The active router IP address is this one. And it has a priority of 110. Okay. Now, standby is local, which means this router, right? And it has a default priority of 100. Okay. Perfect. Okay. Now, if we go to router 1, we can also verify that information. Show okay, so here you can see router 2 state is standby, router 1 state is active. Perfect. This is exactly what we want. All right. Now this is the active MAC address. Very important. so you guys can see what's going on behind the scenes. It ends on 0801, whereas the my standby will end on a different MAC address. So let's go ahead and see if we can see how everything is being load balanced. Okay, so let's jump over to our computer and start making the changes or see the difference. So first and foremost, let me try to ping the loopback. Okay, so we have connectivity. That's good. All right, if I try to ping my router IP addresses, okay, I can pin that, and I can pin the other one. Perfect. All right, fantastic. Now the other router is going to be, the MAC address is going to be ending on 0802, whereas the main or the active is 0801. All right, so keep that in mind when you guys see what's going to start happening. And this is how you can see the load balancing in real time. So first, let me clear this up. All right, now I'm going to clear the ARP table. And let me see what we know about MAC addresses. Okay, so far we know about MAC address of this device, or the 254, right? This is router 2. We do that one more time. Okay, that's all we know. We only know about the MAC address of the router that is directly attached, or in this specific situation, I have the physical IP address. I do not have, so far, the virtual IP address. But now, after a couple seconds, here we see that the virtual IP address, okay, that we know right now is the device that ends on 0802. Okay, now remember, guys, the router that ends with 0802 MAC address is router 2. Okay, now if we do a ping again, let's see. If we do a ping, okay, to the loopback, okay, so it was successful, meaning this computer went to this IP address through router 2, okay, and it received replies from the loopback. If we try to do that now, again, let me show you guys something really interesting. Okay, let's ping that again. Okay, that was successful. verify the ARP. All right, great. Okay, now we're back on to the MAC address of 0801. Let's ping one more time, and we do have a reply. Look at the ARP cache. Okay, we see the 0801. If we ping, we're gonna have a success reply. Okay, now let's clear that. Now you learn about 0802, and if we ping, it's going to make a successful reply. So now let's go ahead and shut down the interface. Over to router 1. Okay, shut down the interface on this router 1. Before I do that, I'm going to create a perpetual ping. Okay. And I'm going to shut down this interface. My interface went down. I lost connectivity. But I quickly regained connection once again, because now I'm using a different, or the backup. So this is a example of how load balancing works and the configuration for it. I hope that you guys find this video helpful, and I see you in the next.